Tonight's speaker, Peggy Lemaux, obtained a PhD in microbiology at the University of Michigan in 1997 and was a postdoc with Stanley Cohen, the Nobel laureate and co-creator of recombinant DNA technology. So Peggy's career has really spanned the recombinant DNA revolution in medicine and agriculture. She worked for 2 plant breeding companies prior to starting as an academic, where she joined UC Berkeley, University of California at Berkeley, in 1991 as an extension specialist. And she does genetic research on ways to improve cereal crops, that's barley, wheat, and rice, and a few others, and leads a statewide outreach program to educate the public and professionals about biotechnology, genomics, and modified foods. Peggy's research projects have included the development of faster germinating barley with improved starch characteristics for the brewing industry, an industry that we in Oregon take very seriously. Thank you, Peggy. Her laboratory has also produced a hypoallergenic wheat variety for consumers with wheat allergies. And with funding from the Gates Foundation, she's working on nutritionally enhanced sorghum to help feed poor Africans. I think you'll hear something about that tonight. Peggy has published over 100 peer-reviewed scientific papers and is a fellow of the American Association for the Advancement of Science, the largest scientific society in the world. Recently, she was elected president of the 5,000-member American Society of Plant Biologists. Peggy has produced numerous materials to aid K-12 education that have been distributed widely. And you might have seen as you came in 3 of the displays she's produced, and they're making the rounds at local high schools this week and next. So take a look at them, and you can have a cookie after the lecture if you want and discuss them with Peggy. So when I talked with Peggy about giving a lecture in this series, we went back and forth. Of course, she tried to say no first. I couldn't let her get away with that. But what would it be? Because she works in a lot of areas and pretty much knows everything about these subjects. So finally I said, just talk about what you feel passionate about. And that apparently is feeding the poor. A large fraction of the estimated 9.1 billion people that will be on this planet by 2050 are estimated to be malnourished or at the margins. As Peggy wrote, quote, even today there are 923 million chronically undernourished people in the underdeveloped regions of the world and increasingly even in the developed world. Through improvements in crops and agricultural practices, crop yields have steadily risen, but those rates are beginning to decline. New methods and improved crop species are needed to provide adequate food in an environmentally friendly manner without increasing the area of cultivated land. I think Peggy feels strongly that genetics in all its forms has large contributions to make if society permits it. I think tonight she will explain some of the approaches, possibilities, and consequences of our choices. So please help me in welcoming Peggy Lemaux to Oregon State.
I kind of feel like he already gave my talk, but hang in there, because this is something that I am very passionate about, and it's something that I think most people don't think about on a daily basis. And if I don't do anything else tonight, what I'd like to do is sort of sensitize you to, well, I usually start out this way, and I can't see everybody out there, but I always have to ask, how many people in here have visited a farm? I'm guessing it's going to be higher than in the Bay Area. In the Bay Area, you know, I might get 5, that's it. And then the next question is, how many people grew up on a farm? I did. And so I really feel like I have a perspective that many people don't have, and because of that, I think there are many things that they don't appreciate. So what I want to try to do today is or tonight is to try to give you a feeling for some of the statistics that I've fallen upon that really are, to me, jaw-dropping, and it's something that I'm guessing most people in here haven't thought about, maybe ever. And then I want to sort of take you through, how we're trying to meet some of those awe-inspiring statistics. And then I want to give you a couple of examples in developing countries where I think the situation is quite different than what we encounter here. So this is what we're faced with when you think about the world population. And you see, I got to figure out how to do this here. Because he said there's one button, if you press it, it gets rid of everything. And so I'm like, I don't want to press that one, but this is it. Okay, great. So, but you see images like this, and like this, and like this. We don't, actually, this is a beach in China. And it's just completely umbrellas, just from one end to the other. And just go, wow. We do have a lot of people on this earth. And, we have pretty efficient agriculture here, but it is going to be a challenge. So these are some of the jaw-dropping statistics to me. Maybe you're all used to it, that I'm going to present now. In less than 40 years, the number of people is to increase from 6.7 billion to 9 billion. So that's like inviting 9 people over to dinner, and then everybody shows up and it's 12. And you go, oh, crap, I only fixed enough food for 9. So it's a relatively large increase. So one of the questions that I'm going to address is how did we get into this situation with so many people? Second question, increased food demand will require world agriculture to rise by 50% in less than 20 years. So I remember statistics that we'll need to produce more food in the next 50 years than we've produced to date in the world. That's jaw-dropping to me. So the question is, what will we do about that? So I'm going to cover these 2 questions as we go along. So I'm going to first cover the first one about how did we get to this many people on this earth. So the first time I saw this, this was a jaw-dropper. Because you're going along and you think, okay, da-da-da-da-da, that's population increase. And so 2,000 years ago, 300 million people in the world. Today, that's how many people are in the United States. These are 2 more statistics. 2,000 years ago, 500 people were added to the world every day. 500. Today, 400 times that, added to the world every day. 200,000 people are added to the world every day. That has a lot of implications for food production. I'm sure you were able to figure that out. So I want to just take you through sort of how this all happened. So I'm sure you've heard the term hunter-gatherer. What did that mean? That meant that people would come to a place and they'd look around to see, what they could eat. They'd eat whatever was around, and then they go, crap, what are we going to eat tomorrow? So then they'd move someplace else, and they go, oh, we figured this out while I was sitting here. I'm not used to having this like this. Usually it's up there, and I can wander around like I do. But they would move from one place, eat all that food, and then they'd move to another. That's hunter-gatherer. So that's what people did before agriculture came along. So then about 10,000 years ago, people thought, maybe that's not such a great way to live. I don't know what they thought. But they decided that they needed to do something with agriculture. So when that happened, there started to be a little more of a reliable food supply and a more settled existence. So they could go someplace, they would learn how to cultivate crops, and so they didn't have to move every day to find their food. So when that happened, then people felt more comfortable, and so there was a dramatic increase in the birth rate. Because they felt comfortable that they could provide for their children. But the interesting thing is, if you look here, the birth rate didn't really do anything. We're having lots of kids, but it didn't realize itself as an increase in population. Why is that the case? Things that we don't think about today. Famine, we don't here in the US think about that. War, we do sometimes think about that, but not here in the US per se. And disease. And this is an example of the Black Death that really wiped out hundreds of thousands of people. So this really kept the population down. So that's what made it look flat in the graph that I just showed. So Then, in the last 80 years, population really started to increase. We saw it on that graph, whoosh, like this. And so the question is why? Okay, so there are really 4 reasons. There are probably more, but these are 4 major reasons. People had a lot more money, and there were people to provide food. If you gave somebody money, they would provide you with food. So you didn't necessarily have to raise your own food. You could actually go out and buy it. And so with a bigger income, you could do that. Improved housing and public hygiene. So part of the reason that with the Black Death that happened was poor hygiene. And they were allowing the microbes to get into, the parasites to get into the water. Now, not so much a problem with infectious disease as there used to be. Food production became more dependable. I've already mentioned that because people were able to produce more. And something that I guess I didn't really appreciate until I went to China is we really depend on transportation to get the food to where we need to go. So we think, oh, we'll just go to the store. Well, it got to the store because there's an incredible network of roads that get it to our stores. Not so much the case in China. So it's much more difficult to get food from where they produce it to where people live. A lot of people live in the big cities. And then also another reason for the increase in population are medical advances. So they could, identify diseases, they could treat them, and so fewer people died because of that. So if we think about, places that we know, like the United States and Europe, industrialization, that is all the things that I just talked about, food production, well, a lot of other things as well, but that occurred over a very long period of time. The difference is, if you look at developing countries, South America, Southeast Asia, Africa, basically these improvements are happening in real time overnight, so in the last 50 years. So what it took us quite a long time to sort of get used to and adjust to is really happening very fast for these countries. So that puts a lot of pressure on the food production system and on transportation and every other thing you can imagine that has to do with foods. Okay, so this is also kind of, for me, jaw-dropping. So if you look at population growth in developing countries versus the less developed versus developing countries, there was a 16-fold increase in population in the less developed countries over this period of time. Okay, so that's 16-fold increase. So you go, okay, that's great. Now, how are you going to feed all those people? Okay, well, the problem is that in less developed countries, that didn't happen. So you don't see a 16-fold increase here over this number. You do see a 16-fold here, but not here. So it didn't keep up. So food production didn't keep up. So that's a huge issue in terms of having enough food to eat in these countries. Why? As I said, because it didn't go up. Grain production was only 1.5-fold versus 16-fold increase in population. Okay, so the question is, why did that happen? So again, it's not something that I think about every day, but it was really interesting to sort of follow this and to try to understand really how this happened. So, and you really see this in China big time, is people are basically leaving the countryside. So a lot of people like to think about farming and how bucolic it is and growing your own food. And I mean, I agree with that, and I used to be involved, but it is a lot of work. And anybody in here who's been on a farm knows that. And so a lot of the people in China are moving away from the countryside into the cities, because in the cities they can actually buy goods. They can buy things, and they can't do that. The road infrastructure is not there for them to actually get. And I'm making generalizations, but I traveled with a bunch of Chinese people, and they agreed with me that this is really a big issue, is that they don't really have a way to get goods in the countryside, so they all want to move to the city. So people are moving away from these rural areas and, of course, farming, so it makes it more difficult for farming. And they go into urban areas. And the urban areas, and again, I mean, I hate to keep mentioning China, but it was that and my trip to Africa were probably the things that got me into thinking about this. Because I stayed in Shanghai, and we stayed right on the river. And all night long, you'd hear these boats coming in, put, 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 put. They're all just filled with food, food all night long. And then you wake up the next day and put, 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 all day long. Because they have to bring all the food in for all the millions of people that live there. Because they don't grow things in Shanghai. They have to bring them in from the countryside. So clearly that puts a lot of pressure on agriculture to be able to grow them and then to be able to ship them and get them to the people that get the goods to the people that need it. Okay, so that's not the whole story when you think about food and the difficulties getting it. I think this is also a very interesting statistic. The type of foods that people eat also have an incredible impact on how agriculture is going to have to produce things. So this is a comparison. If you look at the kinds of things that people eat in India versus the United States, you can see, I'm still worried about pressing the wrong button here. So you can see that in India, a lot more cereals, beans and lentils compared to the United States. And then you get down to milk products, meat, poultry, eggs, fish. You know, whoosh, we're over on the other side. So this has a huge impact on agriculture and what we have to do. And the reason is, and clearly this is changing. And if you listen to futurists who talk about what the issues are going to be with food production in the future, this is one of the big ones. As people change from a cereal and vegetable and fruit-based diet to meat-based diet, it's huge. Now, why is that the case? This is another jaw dropper. The transfer of energy from plants to humans through beef. Do you understand that? It's the amount of calories, basically, in a plant that's then fed to an animal, and then you eat that animal instead of eating the plant directly. That efficiency is 1%. That's an amazing difference because it means that you have to grow a lot of plants and you feed them to the animals and then you eat the animals. You know, if we were to convert to back into more of a diet, I mean, the sad thing is that it's happening in the opposite direction. But if we were to move into that kind of a diet, we would spare the agricultural system in a big way. And it has actually affected my eating patterns, just knowing that this is the case. So I hope if you take home nothing else that perhaps you'll remember this the next time you grab a steak. Right, guys? You're going to remember that? Okay, good. Okay, so then that, you know, that brings you to the question, how, you know, how have we dealt with this? How have we increased food production over time? So from 1860 to 1978, we just said we need more food, and we've got a lot of land, and you know we have that capacity here in the United States. So let's just increase the land use. So that's great, you can do that, but since 1978, we sort of reached a peak where we said, okay, that's the land we want to devote. Europe reached that much earlier. And so because the land size remained the same, that's the amount of land that's used to grow crops, remained the same, but the number of people went up, right? We saw that already. The land per person dropped by 25%. So that's a pretty, I mean, 25% is pretty huge. And so the question is, well, so how do we manage? Because we still aren't paying very much. We pay the average US person, sorry, less than 10% of our income is spent on food. Sorry. Okay, so that's how we dealt with it before. The question is, okay, so of all that, and we're going to have a quiz, guys, so all of you students who are sitting in the front row here, I'm going to count on you guys. Okay, so what do farmers produce? So we see these grocery store, I'm sure you all see these grocery store shelves just packed with stuff. All the urban people that I talk to, and I know this sounds very trite, but it's really true. They don't really get it where it actually came from. It didn't come from a Safeway truck, originally anyway. But anyway, what do farmers produce? So this is pretty interesting. globally, there are about 300 crops. I actually think there must be more because in California, we grow 300 different crops. We are the #1 agricultural state, although most people don't know that, but we are. So it's probably a little more than 300. But 24 of them provide most of the food. I think it's 85% of the food. Oh, no, it must be lower than that. But 8 supply 85% of the food. So 8 crops supply 85% of the food that we eat worldwide. 3 account for over half of our food. Wow. Okay, there they are. Okay, guys. Boop. Okay, you got it. That's the easy one. Okay, how about, okay, so we got that one, corn. That. Nope. Wheat. Good, you're good. Good. Okay, yeah, that's wheat. And this one, I hope, is kind of a giveaway. Yeah, rice. Okay, so 3 of those account for over half of the food. Some of them through feeding to animals, but you know, some of them are direct foods that we eat. That's U.S. Yeah. But I would have to say, I mean, certainly rice is right up there no matter what. So, and corn, well, I won't go into that. I have some prejudices, but yeah. Okay. So then let's take a look, and I mean, I'm sorry to keep using jaw-dropping, but when I got these statistics, I was like shocked. Let's look at productivity in U.S. agriculture. At first, it doesn't look so good. Okay, so this is looking 1930 versus 2009. The percent of people involved in farming, and I know when I grew up, which was not then, but you know, there were a fair percentage. So you come into a group like this and you say, you know, how many people, you know, grew up on a farm or whatever, and you know, half the people might say yes. Not so much anymore. So 21% in 1930, 0.7% today. Wow, involved in farming in the U.S. This is U.S. The number of farms have certainly decreased from over 6 million to about 2 million. So both of those decrease. So you say, oh, okay, well, what's going on here? Okay, well, what's going on is the productivity of the average U.S. farmer increased. Look at these numbers. I mean, to me, this is like, in 1930, that's here, 1 farmer would feed 10 people. 1960, you know, 30 years, okay, you doubled. Okay, then 1990, you've gone up tenfold. 2009, 1 farmer will feed 155 people. That's pretty awesome, actually. I think that's pretty impressive. So that's how we've managed, is that it's become more productive to do agriculture. And how has that happened? Well, there really are sort of 2 major reasons for this. And it depends on who you talk to and what statistics you read. But clearly, these are genetic improvements in the crops and more efficient farming practices. So using fertilizers, using tractors, using all kinds of things. So that's really how they've managed to increase productivity. So I hope I've shown you a little bit about where we've come in terms of population and sort of how it happened. And now I'd like to sort of talk about this increased food demand for world agriculture production and what we can do about it. So since the 1930s, and I kind of covered over that, but it's like right in here somewhere, classical breeding and these inputs that I talked about before and farm mechanization led to really pretty dramatic. So this is wheat, corn, and soybeans, like whoop. So I was drawing a line through that today, and it's like, yeah, wow, that is pretty. So it's just completely flat. You know, there are little variation here and there, but you know, until the 1930s, pretty much flat. So just to put this in perspective, if we were to take how much we could produce on a farm in the United States in 1929, how much land it would take to produce food for today, or almost today in the 1990. That's how much land it would take with 1929 production statistics. If we use then instead 1987 production, I really have to update this map, but this is, you can see dramatic difference in the amount. This is the amount of land it would take using 1989 production to make enough food to feed people in the United States. So this is really a dramatic example of how much the improvements in agriculture and the plants that we grow have done for food production. So that gives you an idea through classical breeding approaches. But what I want to say, and I want this message to go home as well, is that a lot of people get up and they talk about different farming systems and different ways of doing things. And I'm a person that believes in using as many approaches as we can. Use the best of every approach that we have, because there really isn't any magic bullet for any of these. And so we really need to take a look at everything that's out there and use the best that we can of everything. So in the past, how have we gotten new varieties? So I use wheat as an example here. So this is an old variety of wheat called Triticum monococcum. This is a modern variety of wheat. And so the question is, well, if we had a characteristic in this ancient variety, let's say a disease resistance, and we wanted to get it into this variety because we wanted it to be disease resistant, how would we do that? So since most people, through classical breeding, but since most people don't think about genetics, and they kind of get really scary when you say, well, wouldn't you like to know about genetics and how we do? So what I did when I first came to Cal, when I went out to talk to people, is I said, if I want to understand something, well, the stock market isn't a good example, but I don't understand the stock market, but then neither does anybody else. But I need analogies. And so what I did was I took, so the genetic information in cells, in our cells and plant cells, is made up of DNA. You guys all know this. And that DNA is made up of chemical units. So what I did was I represented every one of those chemical units with an alphabetic letter. When I do that with wheat, it takes 1.7 million pages of information to represent all the information in a wheat plant. And quite frankly, humans don't have that many books. So I sometimes think maybe plants are smarter than we are. I'm not sure. But there's even more genetic information in a wheat plant than there is in a human being. But that's a lot of information. So the question is, when you do classical breeding, what you do is you cross one plant with another plant. So what happens to that 1.7 million pages of information? So now we're going to represent one of the plants, our wild variety with the cultivated variety, and we're going to cross them. And so we've got 1.7, I've already given the answer to this, so you guys passed this test. Do you end up with 3.4 million pages of information? You just clomb this with that and you get double? No. Genetic rules say that you can only end up with 1.7 million pages of information. So when you do that, that means, wow, you get about half the information from one set of books and half from another. This is why we don't look identical to a sibling, let's say, because it's the same thing with human reproduction. So, we don't look like either of our parents identical, because we're going to get half the information from one parent, half from another. So this is the process that they go through when they do classical breeding. They do crosses, and the breeder actually can't say, oh man, I want that book right there. They can't do that. There are ways now where they can tell what are in some of those books, and they can be a little more precise about which books they want, but they still can't, you do the cross, you plant out all the plants, and you get what you get, and you go out and select them. So there's really random retention of the books that are in this cross. Okay, so then we get into the B word, biotechnology or genetic engineering. What about the new genetic approaches that are being used to create crops? So that's called genetic engineering, biotechnology, GMOs, genetic modification. And in terms of our analogy, the way genetic engineering is done is basically one piece of information. So in your DNA, you have, I sort of compare it to like a cookbook. You have a set of recipes that define, like, whether you have curly hair or straight hair, whether your eyes are blue or brown or whatever. And those recipes dictate what you're going to look like. A plant's the same way, whether the fruit is red or yellow, whether it smells you know, like vanilla or something else. It's all in these recipes. And the recipes we call, in genetic terms, we call them genes. And so moving genes around may change characteristics of a plant or an animal. And in terms of the analogy, a gene is comparable to a half page of information. The other thing that's sort of similar here is if you all use word processing, you kind of know, like let's say you wrote 2 papers, and you guys don't do this because it's called plagiarism, but you might think, oh yeah, man, I read something really interesting, and I know the first few letters in that thing that I read, and I want to move it into you're going to move it in as a quote, so it's not going to be plagiarism. And I want to move that into my new document that I'm writing. And in some ways, that's similar to the way genetic engineering is done, because we can go in, we can look for this half page of information, because in some cases, for many plants, all of these books have been read now, 1.7 million, they've been read. And we can go through and we can pick out that half page of information that we want to use. And with word processing, you can go in, you can cut it out, and then you can paste it back into your document. And we can actually do that with chemical scissors and chemical paste to put it into that book. What we can't do at this point, and we're working on being able to do that, is that it will insert randomly in the genome, just as when you do the crosses with classical breeding, you don't really have direct control over what ends up next to what. It's the same way with this. So this is sort of genetic engineering, and I like for people at least to understand it at this level, because if you don't understand you know, like what classical breeding is and what that means in terms of genetics and how things move around versus genetic engineering, it's really hard to talk about risks and benefits. Okay, so that's genetic engineering. And so the question is, what's in the commercial field in the United States? So these are the things that are out there, and I know you all had a big discussion here in Oregon in November about genetically engineered sugar beet. I was actually really surprised. Now, 96% of the sugar beet in the United States, this is 2010 figure, 96% of it is genetically engineered. It's a single variety, or it has a single new trait in it. So that's really pretty phenomenal. We can talk about risks and benefits, because I have some issues. But anyway, genetically engineered canola, 88% of 2010 acreage. 93% in cotton, 93% in soybean, 86% in corn. And alfalfa is lower. This is a 2006 because it kind of went on the market and then it was taken off, and now it's back on, so that number will probably go up over the years. So these are the things that are the major crops that are out there. And so when people say, oh, isn't everything genetically engineered? Well, the answer to that is no. Everything's genetically modified to me because of the way classical breeding is done. So genetic modification means genes are moving around, and that certainly happens in classical breeding, but not genetically engineered. The reason why people think most things are genetically engineered, or GMOs, is because a lot of products from soybean, for example, soybean oil, soy protein, canola oil, even cotton meal, cornstarch. A lot of those are in our processed products. And so if you look at processed products, it's really correct. People have different estimates, but somewhere around 80–85% of processed products probably have a genetic engineering ingredient in them. The only whole foods that are out there are genetically engineered sweet corn, genetically engineered squash, and genetically engineered papaya. And I was just telling Hiro, who's from Japan and just came back from Japan, that the genetically engineered papaya was developed by a public sector scientist, and it just got approved in Japan. And the interesting thing he told me was he's worked for 10 years to get it okayed in Japan. And he said, actually, what was interesting, it wasn't really the fact that it was genetically engineered that it took him so long, but Japanese people don't eat papaya. So they don't even know what it is. So he said, it's like, give it to them, but they don't even know what to do with it. So, but anyway, that's now been approved in Japan. So it's the only whole food in Japan, I believe, as well. Okay, so that's in the US. So that gives you a picture in the US. But what's the situation worldwide? This is just a graph that shows, this is now not just the US, this is worldwide, and we're talking about industrial nations, which have kind of leveled off, developing nations that's kind of started slow, but it's going up now. And so there is a man who does, his name is Clive James, and he does these surveys every year. And so there are 15.4 million farmers in 29 countries that have planted genetically engineered crops. So when I got ready to come up here, I usually have this in terms of Texas or whatever. I said, no, I'm doing it in terms of Oregon. So 6 times the size of Oregon, that's the acreage that is planted to genetically engineered crops worldwide. And another surprising statistic to me, 90% of the farmers that are actually growing these are small, resource-poor farmers in developing countries. So you might not think that, I certainly didn't think that. So that was pretty surprising to me. But the other thing that I'm not really all that happy about, and you'll see why in a minute, the advances that farmers in developing countries have are very limited in terms of the number of crops that they have. So it's not necessarily those that are the most value in developing countries. So we have soybean, maize, cotton, canola, and most of it is maize in developing countries. So I have some issues with that. And also the fact that there are really very limited traits. So herbicide tolerance and insect resistance. And I was thinking about that before I came in. And I mean, the thing is, for the most part, most developing countries, they don't have the money to buy herbicides anyway. So that's not going to be very useful for them. Probably insect tolerance, yes, maybe, because they do have disease problems, and they often don't have the capacity to control them in any way. Like we do, we just say, oh, we use pesticides. I was with Pat Hayes this afternoon, and he saw some mildew in his greenhouse. It was like, oh, get the guys in here to spray the pesticides, to get rid of the powdery mildew. I mean, they don't have that option to do that. So if you can build something into a seed, then it's very useful for them. But that, I don't think that it serves a developing country very well. So this is a reporter that I know, and she called me to ask me about this new report that I just showed you the data from. So, what do you think about that? And I said, well, the problem is that, and I was told this when I first started doing this, being the naive person that I am, oh, well, after the companies get done, doing everything for agriculture here, they'll start putting traits in low acreage crops and doing things for developing countries. I don't really believe that anymore, and I don't even know that that's the right way to go. And so fortunately, we were involved in a Gates Foundation project, and I think that's really the way this is going to happen, is through philanthropic organizations that come in and offer money to actually try to solve problems that are needed in developing countries that we don't necessarily have a sensitivity to here, nor would it do any good, and I'm going to give you a couple of examples in a few minutes. And another point that I made that she didn't use in her quote here, but I think it's very important. Although many academic scientists would like to play a meaningful role, they have limited resources to do so. Academic scientists, it's land-grant universities like Oregon State and like the University of California at Berkeley. We're land-grant universities. Our job is to do something for agriculture. And in biotech, we really can't do that anymore. And it makes me sick, frankly. It's just very difficult. And we can go into that in the discussion period if you like. But it doesn't make me very happy. So anyway, that's kind of the way I see it. So then I wanted to kind of think about developing countries, because like I said, I was involved in this project in Africa. And I guess for me, I'd never been to Africa, and it's something over there, and I know they have problems, but hey, I got problems too, until you go there. And then it's like, wow, this is amazing. Africa, so the Gates Foundation really focused on Africa. And here's some jaw-dropping statistics. That's the only region where both poverty and hunger continue to increase, and I'll give an example in a minute. Since 1995, the number of Africans living on less than $1 per day has increased to 50%. Half of the people live on less than, usually when I go out and give talks in high schools and other schools, the first thing I do is I get up and I offer people $30. And I said, who would like to have this for their lunch? And of course, everybody, me. And I said, oh, wait a minute. No, actually, that has to be for a month. And they go, oh, you know, hands go down. And they say, oh, but not only does it have to pay for your food, it has to pay for your lodging, your transportation, everything else in your life. And then all the hands go down. Because that's what people face. And 50% of the people live on less than $1 per day. Okay, that's one. 33% of, and Steve sort of stole my thunder a little bit by mentioning some of this stuff, but I think it's worth mentioning again. 33% of all men, women, and children in sub-Saharan Africa are undernourished versus 17% in the developed world. I think even 17% in the developed world is pretty astounding. I'm not very proud of that either. This one. African farms yielded 19% less ag production in 2005 than they did in 1970. That's 35 years. They're doing less now than they did. And you saw how our production has gone up. That's astounding, and it's not very good for the people who live there, so it makes it pretty hard. And the question is why? Not surprising. Technologies. This is Senegal. You can see how they do agriculture. This is how we do agriculture. That's going to make a big difference on food production, for sure. Another issue is basically they don't have the crops there. They don't get the productivity that we do. And this is just sort of comparing, let's say, oh, sorry. Oh, dear me. What have I done? Oh, okay, there we go. That wasn't the right button, but it was close. So, okay, so if you take a look at maize, sorghum, rice, wheat, and chickpea, and you look at the yields that they get in Kenya and Ethiopia, in some cases India, and then the developed world, you can see the, in this case it's 25-fold more productive in the United States, or in developed countries than it is in Kenya, for example. So they don't really have, they don't, they don't have the technologies, and they don't have the seed varieties that they need to produce the food that they need to feed people. So this is part of the reason why so many people are undernourished. So this leads to a difficult situation in Africa. I've said some of this already. 1 billion of the world's poorest people depend on agriculture for food. We don't. I mean, we do, but we don't ourselves depend on our own food production. And what they're saying here is they do. They do their own agriculture. 820 million people go to bed hungry every day. Malnutrition leads to stunted physical, mental development, increased disease susceptibility. So it's not just that they're hungry. This affects their whole immune system. So this is a medical issue as well. And I was saying to Steve or somebody that because I'm at Berkeley, I don't get a lot of people who are really into agriculture. And so most of my students are pre-meds. And what's been really interesting to see, so we work on nutritional improvement of crops, and many of my pre-med students switch when they're ready to go to grad school. They don't go to medical school. They go get a plant biology degree because they believe that providing people with food and nutritious food is one way to get better health for people, and that they don't have to do it through classical medicine. They can do it through plant biology, and that makes me really happy. I hope they can find jobs. And I do worry about that. Can biological improvements in crops help? And I want to focus on two examples, one of which some of you may have heard of before, vitamin A deficiency. So I'm just wondering, people in here, how many people worry about not getting enough vitamin A? Not as many hands are going up here. No, we don't think about it. But it's incredible what a difficulty it is. And so you can't read this little thing down here, and that doesn't matter. But if it's red, these are people that have clinical problems. They are sick because they don't get enough vitamin A. So it's not a trivial problem. You can see it's also a big problem in India and various other places around the world. Not so much in the United States. We don't think about it at all. We just go get a vitamin pill, or we eat something good that we can. They can't do that. Actually, a colleague who was part of this series, he was the first one, I think, speaker, Ingo Petrikis, knew about this problem, and this was back in the 90s, and he said, oh, man, maybe you could build vitamin A into something that people eat all the time. And what do people eat a lot all the time? Rice. So I said, maybe we could build that pathway into rice. So, but other people say, well, there are other ways that people could get vitamin A. And I remember doing a debate in Washington, D.C. with a woman by the name of Vandana Shiva. And what she said is, well, you know, we don't need golden rice. They just need to eat green leafy vegetables. And I thought, that's great. Do that. But I don't think everybody can. So this is very interesting to me. So you take a rice-based diet and you say, okay, well, how about vitamin A? Nothing. Vitamin C, nothing. A little bit of folate, these are recommended daily allowances here. Iron, zinc, things we don't think about at all. I bet nobody in here, I don't ever think about it. Okay, so you say, as she did, can't you just take rice diets and just supplement them with other fruits and vegetables and meat and add these nutrients? Jaw dropper. Okay, here we go. Okay, so great. So instead of just rice, we'll have rice and carrots. Yay! Vitamin A, good. Vitamin C, not so much. Folate, blah, blah, blah. Okay, we'll add an orange. Oh, now we have vitamin A, vitamin C. Oh, still no minerals. Oh, let's add lentils. Folate, great. And then we add meat. We'll get a little more zinc. And then we add spinach. And then we add da-da-da-da-da-da. Great, now we're there. Now, how many people do you think? Not everyone has that luxury. So that's my thing here, is that great, if there are other ways to do this, and there are other ways to do mineral and vitamin supplements, but my argument to her was use every possible way you can to alleviate these people's problems. And so one of them is through classical breeding. So a colleague in Switzerland has done through classical breeding increased zinc levels and iron levels in rice, almost up to where they need to be. And the reason they could do this was because they could find compatible varieties of rice that had increased zinc and increased iron. And that's great. If you can do it that way, you can use classical breeding. The problem is you can't always solve problems through classical breeding because you don't have the genetic variation that you need. So instead of approaching it that way, this person, Ingo Petrikis, decided to do it. Oh, yeah, okay, that's what I just said. This person decided to engineer rice. And to do that, they introduced two different genes. One, at that time, one was from daffodil, but now they have put it in, the gene was in maize. So they have sort of the basic building blocks there, but they can't quite get it to beta-carotene. But they can do that if they import a gene from maize and one from bacteria. And by doing that, they can make rice make vitamin A or pre-vitamin A. And so this is the progression of vitamin, of gold, what they call golden rice. This was the original golden rice, which you can see, you know, it's kind of golden, but some of it's not so golden. And then there was a new improvement here. And all along the way, people would say, oh, well, you know, that's not going to work because it's not enough. And kids would have to eat like a barrel of it a day to get, and it was true. It was just like judging the computer based on the first computer that covered a city block in New York City, and you say, well, how can computers ever be any good because they're so huge? And you know, now we carry that around in our wristwatches, right? Well, not me, I have Minnie Mouse, but most people have that capacity in their iPhone or whatever. And it's the same way with these kinds of improvements. You need to do a number of them till you get to the place where it's really useful. And so this is golden rice 2 here. And a normal portion now for a child provides half of the child's vitamin A needs. And this is recommended daily allowance. And here in the United States, our recommended daily allowances really are much higher than they need to be. So for a child that doesn't have any vitamin A, this is adequate. This will keep them out of the sort of the disease phase. But there's been a lot of activism against golden rice. And so it really isn't out there yet. It's been in development for over a decade. And they are introgressing it in places like Thailand and Vietnam and the Philippines into local varieties, because the idea for this is not done by a company. This was done by an individual. And so his idea is to get it out to farmers, let them grow it. You know, we're not going to charge for it. We just want them to grow it and provide it to their local people. So to do that, they have to put it into local varieties. So that's basically the process that they're going through now. But there's still a lot of people that don't like this and don't want it. and so it's very slow. So I know that Hingo retired, but he's still really depressed because he got into this because he was thinking of it from here. How can I help these people and these children rise up out of this disease state? And he did this thinking, oh, I can help. And now it's just being held up by people who don't believe in the technology. So that's, and again, I want to say it's not a magic bullet, but it could help, and could help in some examples. Now I'm going to have a tougher quiz for you guys. So second, cereal. That's important in developing countries. It's nutritionally deficient, so it doesn't have a lot of the vitamins and minerals, just like rice. It's a cereal. It doesn't have certain amino acids. And uniquely, it's also poorly digested. And you can see a woman right there who's holding it. So I'm going to let the front row here tell me what that is, and then if you can't do it, then I'm going to let anybody out in the audience who can do it. Okay, guys, what do you think? Sugar. Sugar cane? Yeah. Actually, it isn't, but it's its closest relative. Nobody thinks about this anymore. They use it to make molasses. So that's why you're close, because some of these varieties of this, you can actually squeeze sugar out of the stem, and they did that, and they make molasses. Okay, I'm going to open it up to all the rest of you guys out there. Yay! Woohoo! Yeah. Okay, this is my crop. That and barley. These are my two crops that I love. And this is what we worked on for the Gates Foundation. What is this crop? You guys already answered it. So you'll never forget now, will you? No. It is sort of a warm season crop, so you don't grow it very much here. We can actually grow it in California.
It's increasingly in the livestock industry, really interesting.
Yeah. I mean, it is used, but it's livestock here, but I'll show you that not the case in Africa. So this was our project with the Bill and Melinda Gates Foundation, and to improve its nutrition. So why did they pick sorghum? They actually picked 4 crops. Sorghum was one of them, to do nutritional improvement. Rice, banana, cassava, and sorghum. It's the 5th most important food crop, grain crop worldwide. 90% is grown in Africa and Asia, and arid and semi-arid regions. And it's a staple food for 300 million people. So 300 million people, and many of those people, that's all they eat is sorghum. And so they're obviously going to be nutritionally deficient. Why is sorghum great? And it's why I'm such a big fan, and I'm not a big fan of corn, because it uses a lot less water than corn, and it uses a lot less fertilizer. But in many places, the yields are very comparable. So to me, so it not only can, so global climate change, it can withstand drought. I probably don't have time to tell a story, but yeah, I grow sorghum, and I grow sorghum down in our basement. And so right before Christmas, I put a bunch of plants out, and usually the greenhouse comes and picks them up. But they don't do that over Christmas, so I came back after 3 or 4 weeks. The thing was probably in no more light than this, never got any water, and looked just exactly like what it did when I took it out of the growth chamber. Unbelievable. It just doesn't need water as much as many other crops. So I'm a big fan, and why I'm not a big fan of taking, I mean, I know corn is very productive, but to basically take a continent like this and say, grow corn and don't grow sorghum anymore, doesn't make sense to me, because it really is suited for them, but it does have some problems. So the first nutritional improvement that came out of this project was to make golden sorghum. So it's just like golden rice. So they went in and they modified it so it can make provitamin A. So we've got that. That was not the only thing that we wanted to try to do. And our goal at Berkley is to look at digestibility. So you say, oh, digestibility. Okay. So in Africa, 74% of sorghum is consumed as a cooked porridge. So it's like cream of wheat, only it's cream of sorghum. I've had it. It's not great tasting. But I guess if you have eaten it since you were a little kid, you love it. But so they eat it that way. But of major cereals, sorghum is the least digestible following cooking. This is astounding to me. So if you look at maize, when you cook it, you only decrease by about 4.1%. So if you go from here to there, Sorghum, wow. So what I say to people is this is really a great diet food. So you just like eat all the sorghum you want, and the calories just go out your rear end, many of them. So for us here, that's a great diet food, right? But in Africa, they don't need a diet food. So this is a huge issue, is to work on digestibility and figure out how it works. And so this is what my lab and Bob Buchanan's lab have worked on for quite a while. We have some transgenics in the greenhouse now that we're pretty happy and confident about. So one of the reasons that it's so undigestible, so to me, as a biologist and all, you look at a seed and you go, well, yeah, okay, that's fine, not really that interesting. But look at what you can see when you sever that seed in half and you put it under a microscope that goes up by 300-fold or 1,000-fold or something else. This is what is inside the seed. Isn't it beautiful? It's like, wow, look at all that structure. Because you think it's just like this shiny thing, and you put it in the ground and it grows and whatever. But there's an incredible architecture. And part of that architecture doesn't do sorghum seed very well, because what it does is it basically, these little balls here basically protect a lot of the starch and protein from actually being digested. So it forms sort of an armor or a shield around the protein and the starch. And the enzymes try to get in there and get it, but they can't. And so what we know is we know something about the biochemistry of how this works and why it works the way it does. And so we've gone in and made just a single modification. We've changed a single half page of information in my example that I gave. And by doing that, we were actually able to, and this is just one event, and I've now worked 10 years to have some students who have generated now another 15 events that we're going to be analyzing in the next year. But this one event showed a 25% increase in digestibility. So we're hoping that this really is going to be an improvement for sorghum. And it doesn't really change any, it's a very subtle change that we make. And so it doesn't really change any of the other properties of the seed. Because I remember when we first went over the Gates Foundation, and there was an African guy there, and he said, yeah, you guys are going to be like mucking around with this stuff. And he said, you make anything that changes that seed, we're not eating it. So even if it does provide something that's worthwhile to them, it's one of the worries that I have about golden rice, actually. People around the world love to eat white bread, because we eat white bread here, and they think that's really great. That's what we should do if you have a lot of money and you're really well-to-do. You eat white bread, so people eat white bread. So there's sort of that same mentality about rice, is we should eat white rice because that's what people eat, refined rice. So I'm a little worried that people are going to accept it. We'll have to wait and see. Okay, so I said I would harp on this again. Genetically engineered crops a magic bullet? No. Is farming using organic practices a magic bullet? Farming conventionally a magic bullet? Farming using integrated pest management a magic bullet? No. Future farming will be complex. It's going to require all the skills and technologies that we have available. And I hope people can say open to that, because I really believe that. My stance is coexistence. It's taking all the best of the technologies and using that. We've got some big problems, and we're going to need big answers to sort of solve those problems. So I think that I'm done, except that I want to just say this is what I do for a living, is I go out and talk about these things, and I write about these things. And we have a lot of resources on our website. It's very easy to remember, and it's not just about biotechnology. It's about all the things that I've talked about, ucbiotech.org, and my talk will be up there as well. And we have a lot of educational stuff, like Steve mentioned, that we have out there. And I thank you very much for listening, and I'm willing to take questions.